Hello everyone, welcome to my YouTube channel. Today we are going to see another interesting topic that is called as principles of mechanical product designing, that you can call it as the guideline for mechanical design engineers. So designing engineer have a lot of responsibilities which they have to perform while developing any product. Like they have to see the functionality of the product, they have to ensure that whatever they are designing, it is a manufacturable and it is a cost effective also, because whatever is the product, if it is looking good but it is not reliable, it won't accepted by any customer. And if the product is looking good, performing very well, but cost is very high, then also customer won't accept it. So from the all the aspects, designer has to work and optimize its cost, and he has to give a good performance to their customer. So we will see a step by step what are the principles mechanical designer has to follow to design a perfect product for his customer. First step is simplifying the design. Whenever we start any product development, there are a lot of parts going to come. So mechanical designer has to work to reduce the component, because if you reduce the component, then your assembly time is going to decrease, your manufacturing process are going to decrease, and ultimately your product cost going to be down on the downside. So we will see one example. If we have these two parts which are going to be assembled by threading, as you can see, there is one hole and one shaft which both having the threading. But if I have to combine this part, can we make it like this? Because if it is allowing me by functionality to reduce these two component and make it as a one, I will prefer this single component, because what will happen, it will reduce my assembly time, it will reduce my manufacturing processes, and it will reduce my cost for that particular product. And the major difference will come when you have a like many components, then this tolerance stack up will create a problem, because a particular part will have its own tolerance, and when it is going to be assembled, then that assembly tolerance will get add on in the other assemblies. So it's better to have a single component instead of 2 3 4 components. So next stage is coming, like a precision assembly. So for that we will see this example. If we have to assemble these two components, like you can say that a socket and its cover. On the socket side, we have two rectangular hole and one circular hole. And on the cover side, we have one protrusion. So while assembling, anyone can match that socket on or that protrusion on any socket. So it it might be not correct by functionally, but that assembly person is not knowing that. So he can assemble at any direction. So to avoid this mistake, we can add a simple notch on both on one part and protrusion on the other part, as seen on the second image with the red mark. So what will happen if we add this small detail? So if you have that notch on the bottom side and protrusion on the top cover, so if you try to match that part in any direction, it won't fit until and unless it come to that pocket area. So this small detail will make huge difference while doing the assembly, and ultimately it will reduce your assembly time. Correct? Second stage, standard components and material. In today's world, we have a lot of materials are available. Non-metallic, metallic, composites. That from these standard materials which are available in the market, you can select a suitable material as per your functionality, as per your cost, and the availability in the market. Because if you select a material which is not suitable for your manufacturability, then also it is not useful. If it is very higher cost, then also it is not useful. So you have to maintain the triangle, like functionality, then availability, and the cost of your material. So on that basis you have to select the material for your particular component. Next stage is coming the standard components which are available in the market. Means if you have to do the assembly, basically you will go for any kind of fastener rivets or any kind of plastic rivets or plastic push fits button. So if they are readily available in the market, you can select it from the off the shelf. Because if you select it from the off the shelf, then it is easy to procure, and you no need to go for any new product development for that standard components. So that will reduce your cost, your time. And the third point is coming here is a weight reduction. If you have selected particular material for the component, then you will design for particular manufacturing process, and again you will go for the CAE. So once you do the CAE and you found that your material is performing well, your component is safe, then you try to reduce the weight wherever it is possible. Because whatever weight you will reduce, it will ultimately reduce your cost of the product. Third stage is knowledge of processes. So processes including manufacturing processes or any kind of post process on the product. So there are a wide range of manufacturing processes are available in the market, including injection molding, vacuum forming, casting, press brake and forming, machining, forging. But you have to select whichever is the best for your product. So while deciding this particular manufacturing process, you have to consider which kind of fit and finish you require. Like if you see, you have your product assembly with you, and whatever kind of fitment you are going to do, you have to decide before you are going to select the manufacturing process. Means, like if you want a clearance fit or transition fit or sliding fit, so according that your tolerances will be defined. And once your tolerances will be defined, you can define your manufacturing process. Because each manufacturing process is having its pros and cons in the form of cost or product quality or tolerances. So according that you can decide your manufacturing processes. So after deciding your manufacturing process, another point you have to define is the post processes. Like if you want your component to be strong, you have to do a heat treatment on that. If you want your product looks good, then you can go for the painting, any kind of coating or anodizing. So these are the post processes also you have to define, so that including all these things you can calculate the cost of your product, and according that you can shuffle these things. So these are the main 3 points which every mechanical design engineer have to understand before designing any product. So thank you everyone for watching this video. Do subscribe, like, comment and share, and see you in next video. Thank you once again.